All right, guys, so that is the basic idea behind solving trig equations. All right, so let's take a look at this one. 3 tangent squared x minus 1 equals 0. Again, pause the video here, try it yourself, see how far you can get, see what you come up with, and then come on back once you have it. I'm going to add 1, divide by 3, so I have tangent squared x equals 1/3, square root both sides, and when you bring in your own square root, you have to remember to go plus or minus, so I have plus or minus the square root of 1/3, which is then going to be plus or minus 1/rad3. Now, when you have a plus or minus like this, you have to consider both. So I like to write them separately. It makes it easier for my brain. It makes it better for me to work with. I have tangent x equals positive 1/rad3, and I have tangent x equals negative 1/rad3. So we're going to treat these two situations separately. A tangent equaling a positive is the same as a negative over a negative, and tangent is TOA. So I'm now going to look at this and find where I have an opposite of positive 1, an adjacent of rad3, that makes a 1, 2, square root of 3, an opposite of negative 1, an adjacent of negative rad3, that's a 1, 2, square root of 3. We have little 30-degree reference angles on each of those. Looking over here, tangent x equaling negative 1/rad3, that could be a negative on the top, or it could be a negative on the bottom. Either way, I'm looking for TOA. I'm looking for the opposite and adjacent pairing to go with that. So an opposite of negative 1 with an adjacent of rad3, that happens right here. That's a 1, 2, square root of 3. An opposite of positive 1 with an adjacent of negative rad3, that happens right here. That's a 1, 2, square root of 3. Again, those are little 30-degree angles. Now, sometimes people find this part tricky, but stick with me here. When you solve two different situations in a trig equation, it's usually best to look at your answer choices on the same graph. I've got this guy and this guy, and I want to put it on the same graph and see what happens. So if we go with a new graph that shows all four of them, we've got a 30-degree, we've got a 30-degree here, we've got a 30-degree here, we've got a 30-degree here. The reason we like to look at them all on the same graph is because it makes it easier to spot those even intervals all the way around. Now in this case, going from one to the next, if this much is 30 and this much is 30, that means we've used 60, this much is 120. So we've got 120, then a 60, then 120, then a 60. We don't have even intervals all the way around. So now that we've determined that, we can actually ignore this and go back to the original two that we were dealing with, because it'll be easier to look at it that way. So based off of this axis here, I have an answer of x equals 30 in radians is pi over 6, plus we're spinning in half circles, so it's going to be pi over 6 plus pi n. And then also an answer will be 5 pi over 6, that's 150 degrees, plus we're spinning in half circles because it makes the straight line, pi n. The answer to this equation is x equals pi over 6 plus pi n and 5 pi over 6 plus pi n. Now let's think back to some basic equation stuff that you need to know. If I give you a problem like 2x equals x, some people might be tempted to look at this and go, ooh, I'm going to divide both sides by x, so I get 2 equals 1. But that's clearly not the right answer. You can't do it that way. The correct way to solve 2x equals x is to subtract x, get everything on one side. 2x minus 1x is 1x, and on the right hand side we'd have 0. X equals 0. That's the right way to do it. Again, look at something like this. if we have, say, x squared equals x, some people would be tempted to divide by x, cancel, cancel, they get x equals 1. And that looks totally fine, except when you remember, okay, if I've got x squared equals x, technically speaking, the right way to do this is to subtract x from both sides. You get x squared minus x equals 0, and then you factor. So we have x times x minus 1 equals 0. So then this little guy equals 0, and this little guy equals 0. We have two little baby equations, one with x equals 0, and one with x minus 1 equals 0, so we get x equals 1. So while this equation looked okay, it didn't give us both of the correct answers. This equation actually has two correct answers. So what is going wrong in these two situations? Why are we getting wrong answers when we're dividing by the variable? Well, keep in mind, when you divide by a variable, you lose information. Information is contained within those variables, and when you simply divide them away, you lose that information. So you can treat this situation two different ways. You could say, never, ever, ever divide by a variable. Never divide by a variable. Don't do it. You're not allowed to do it. It'll mess you up. Or if you think that you can remember, you can say, okay, well, as a shortcut, I can divide by the variable, but then I always have to remember to set the variable term equal to 0. So again, one, you could tell yourself, never divide by a variable. If you're the type of person that forgets the small details, just don't allow yourself to do it. Never divide by a variable. It's not okay. Or you could say, well, you know, if I'll remember it. So I'll go ahead and divide by a variable because it makes a shortcut. And then I just have to remember to set the variable term, the term that I'm dividing away, equal to 0. Coming back to this equation again, x squared equals x. We've done the don't divide by a variable version. That's right here. But if I allowed myself to divide by a variable as a shortcut, I get x equals 1. And then I have to set the variable term that I divided away. I divided away x. I have to set the variable term equal to 0, and that gives me my second answer. As long as you set the divided away variable term equal to 0, you are allowed to divide by a variable, as long as you don't forget that detail. So now let's look at a slightly more interesting problem, kind of like this. If we have, say, xy squared minus 2x equals 0. The don't divide by a variable version says, well, let's factor out x. We get y squared minus 2 equals 0. So I'm going to set this guy equal to 0. I'm going to set this guy equal to 0. I get x equals 0 and y squared minus 2 equals 0. So I have y squared equals 2, square root, square root. I have y equals plus or minus rad 2. I get 3 different answers. The go ahead and divide by the variable version shows xy squared minus 2x equals 0 if you move the 2x over. We can divide both sides by x, cancel, cancel. You get y squared equals 2, square root, y equals plus or minus rad 2. But we also have to remember that the term that we are dividing away, x, cannot equal, we have to set that equal to 0. So we get x equals 0. Same answers here as here. So now we get to the more interesting stuff. Take a look at a problem like this. Cotangent x times secant squared x equals 2 cotangent x. The don't ever divide by a variable term group is going to say, all right, well, let me subtract 2 cotangent x from both sides. Subtract 2 cotangent x from both sides. So I have cotangent x times secant squared x minus 2 cotangent x equals 0. I see cotangent x in both terms, so I can factor out cotangent x. That'll leave me with secant squared x minus 2 equals 0. So now I can set this guy equal to 0, I can set this guy equal to 0, and that'll give me cotangent x equals 0, and secant squared x minus 2 equals 0. Pausing this problem for just 1 second. Scooting over here, if we started again, cotangent x times secant squared x equals 2 cotangent x. The go ahead and divide by the variable group would say divide by cotangent x, divide by cotangent x, so cancel, cancel, you get secant squared x equals 2, but then whatever you've divided away, cotangent x is also set equal to 0. So it's a really big shortcut. You get to the same place, essentially, but with less work. The danger is if you forget to set the variable term, the term that you're dividing away, equal to 0, you're going to lose half your problem. So continuing to solve, again, since it's essentially the same problem, I'm going to solve this guy over here that I started with before. Cotangent x equals 0. I'm going to turn everything into sine and cosine. So I have cosine x over sine x equals 0. I'm going to multiply by sine x, multiply by sine x. I get cosine x equals 0. Cosine x equals 0. I'm thinking about quadrantal angles now. So I have x equals 90 and 270. So looking at those on a graph, I've got 90 and I've got 270. And I'm going to hold on to that for just a second. Now I'm going to add 2 to both sides. I get secant squared x equals 2. Square root. Don't forget your plus or minus when you take the square root of both sides. So I have secant squared x equals plus or minus rad 2. I'll go ahead and make 2 separate setups. Secant x equals rad 2. And secant x equals negative rad 2. Putting both over 1, I have hypotenuse over adjacent. That could happen with a hypotenuse of rad 2 and an adjacent of 1. A hypotenuse of rad 2 and an adjacent of 1. That's a 1, 1 square root of 2, a 1, 1 square root of 2. And then over here, if secant is hypotenuse over adjacent, that means the adjacent is going to get the negative. And so what I have is a rad 2 over negative 1, a hypotenuse of rad 2 with an adjacent of negative 1. Hypotenuse of rad 2 with an adjacent of negative 1 gives me a 1, 1 square root of 2. And you see these little 45-degree reference angles all around. So now what you have, when you have evenly spaced intervals all the way around, if 45 and 45 makes 90, 45 and 45 makes 90, that means between these two guys is 90 and between these two guys is 90 as well. Looking at them together, if I added in the 90 and the 270, it doesn't make anything evenly spaced all the way around. It's 90 between these two, but then only 45 here. 45 here, but then 90 between these two. 45, 45, 90. They're not evenly spaced all the way around. So I'm going to stick with these two separate, and then these blue 45s separate. Therefore, my final answer is going to look something sort of like this. X equals the smaller angle, that's going to be pi over 2, and I'm spinning in half circles, so that's going to be pi n, and then the smallest angle, that's 45, so that's pi over 4, plus I'm spinning in little 90-degree angles all the way around, that's going to be pi over 2 n. I know it's a lot, but we will practice more. Thanks for watching. Let me know if you have any questions. Talk to you later. Bye.